This is Brent with Lykins Motorsports, and we're setting up some heads for an upcoming build. These are some of our ported trick flow heads that are going to be going on, I think a 505 cubic inch FE for Mr. Jeff. And these have been ported. They don't have the usual CNC marks in them. It's been hand ported on the exhaust side and the intake side both. Typically these heads flow about 330 CFM, and these have been picked up 20, so these hit around 350 or thereabouts. Some average a little higher than that. And what's improved the most is that we have taken the reversion after 625 thousandths lift. We've taken that away so that the flow doesn't back up. I don't even know if that has been an issue in the past. I have put these heads on out of the box on a couple of different engines with a lot higher lift than that, and these heads never really cease to surprise me. But on the flow bench, they get a little noisy after 600 lift. If it does any damage to the engine while it's running, I don't know. But when these are ported, they don't back up anymore, and they level off or gain up to over 800 thousandths lift. So that's the benefit of the porting package. We gain about 20 CFM, and we only pick up about 8 cc's of port volume. So you can see how the guides are all blended in there, and a little bit of vane work. But what we're going to do today is get these heads assembled, and I'm going to go refresh my mind on the cam specs that we have laid out for this build, and then we're going to assemble these cylinder heads and measure everything and make sure it's right. And we're going to use the Trick Flow 2190 and 1625 valves. These are really nice. They come back cut and everything from Trick Flow. And we have some comp cams, beehive valve springs with some tool steel retainers. And we're going to go through the entire process of how to set these heads up. All right, here we go. By the way, before we're going to start, I've already done a couple of things. The guides have been bore brushed and cleaned, and I've also tapped our feed hole for a 1224 restrictor. So this needs to be done, in my opinion, no matter if you oil through the push rods or through the heads. It's a big hole if you're oiling through the heads, and I would like to see that neck down depending on which rocker arm you use. If you're oiling through the push rods, I typically just close these off altogether. So that step's already been done, and we can move on. So let's go over some component details and selection. Maybe I'll do a video sometime on how to pick a valve spring. It'll probably be too involved for this particular video, as there's a lot of detail in it. But for this combination, I have chosen a beehive valve spring. And the beehives are nice in that they have lighter spring mass. The biggest pro to a beehive spring is that they are so small up top that the retainer ends up being very small and very light, and that plays a big role, especially in some hydraulic roller stuff. For instance, this is your typical steel retainer, for like a 1/550 spring, something like that. If I set that on my scale, 30.5 grams. If we go to this Manley titanium retainer for the same deal, 19.5. If we go to a steel beehive retainer, 12.8, so we're getting lighter and lighter. And then this is the tool steel retainer for these valve springs, 8.4. So look at the difference in between, you know, that retainer, 8.5, and a typical steel retainer at 30.5. Just a huge difference. That ends up, you know, helping you tremendously on your valve train weight. With some of the camshafts and stuff that we run, that's very, very important, especially on FE stuff. I mean, if you look at this intake valve, for instance, this is a 2190, 11/32 stem. I think that these are either 5525 or 5550. I can't remember off the top of my head, but you know, that's a pretty chunky valve. FE stuff is by nature heavier because the valves are longer, and you get into, you know, some of the bigger head diameters. You know, if you compare that to something like, you know, a small block Ford, where the overall lengths are about 5 inches and the head diameters are, you know, 202 or 208, you know, there's a big difference in weight there. And this is what we got into years and years ago when we first started going to hydraulic rollers for FEs. You know, you heard everybody complaining, well, my hydraulic roller FE won't, you know, go past, you know, 5,500 or so. It's because everybody was trying to apply the same technology to the FE, and it just didn't work. You can't use the same aggressive cam lobes that you use on a small block Ford or an LS or something like that on an FE. You can't use the same valve spring pressures that you would use on a small block Ford or a small block Chevy on an FE. So, you know, as the years went by and we did more and more dyno tests, and, you know, I learned to get away from some of the more aggressive cam lobes, and I learned to lighten my, you know, valve train packages up, and that included, you know, changing to non-adjustable rocker arms and things like that. And, you know, that's how we ended up doing a 7,500 RPM hydraulic roller on an FE. So valve train selection, part selection is very, very critical, especially in these engines where, you know, the parts are bigger and heavier to begin with. Here's the spring locator for the beehive. As always, you want your locator to positively locate that spring. You don't want any movement. If you're located at the bottom and then you're located at the retainer, then that spring is going to be very rigid in its mounting. I ordered several different valve lock types for this. I didn't know really where I'd be at on the install height, so these are standard. These are plus 50, and I have some minus 50 locks in stock. So what I typically do with valve springs is I go through and go ahead and check all the Coilbind clearances. Well, I won't check the Coilbind clearances yet. I'll check where these springs Coilbind first, because more times than not, the Coilbind will not be at 1/230, and I'll show you that in a minute. And that's very critical because, you know, that plays into several different things. If you plan for a 1/230 Coilbind and it comes out to be, you know, something like, I don't know, 1/170 or 1/180 or something like that, that's an extra 50 thousandths Coilbind clearance that you're going to have. We try to get these anywhere between, depending on the application, between 50 and 100 thousandths on the higher performance street stuff. This is where your reputable valve spring manufacturers such as PAC and PSI and Manley, that's where they tell you to run. The higher the RPM, the more critical it is to get those Coilbind clearances tighter, as it eliminates spring surge. So I am going to go through and I'll map out all 16 valve springs to see where they bind up, and then we'll go through and see where we end up with just a locator and a retainer and a standard lock on our install height. And then we can kind of make some calculations and see where we need to be. For this type of engine, I'm aiming for somewhere around 160 seat pressure and around 400 open pressure. This is going to be around a 630 lift cam, and that's where we need to head with the weight of the valves and everything that we have. So I'm going to go through and bind all these up and record them, and I'll be back. All right, so we got our Coilbind dimensions checked, and instead of 1'230", we're more like 1'170". So that's why we check things, because there are tolerances to parts and there are differences in parts. And I think possibly some spring manufacturers do that so that guys who don't have a lot of experience don't get themselves into trouble with Coilbind clearances and that sort of thing. So now that we have that, I know where my open height needs to be, and there's a little bit of a spin on this one. The intake lift is 635. The exhaust lift is about 616 on, according to Cam isn't here yet, but according to the low catalog, that's what it should be theoretically. Obviously, we will double check all that when the cam comes on the blocks here and when we're doing some assembly. But based on those two dimensions, what I'm going to do now is just roll through and check all my install heights, and then adjust the install height with shims, and try to get those Coilbind dimensions nailed in there, and also check our spring pressures. So I'll go ahead and do that now and map out our install heights, and then show you how the spring pressures measure up. We got our install heights all mapped out and adjusted, and I did set the exhaust valves a little bit tighter than the intake valves, just because there's a little bit less lift on the exhaust side. It will have a little bit higher spring pressure. That doesn't bother me. That actually helps in a lot of situations, as the piston is chasing the exhaust valve back down to its seat. If something happens and you have a valve float or a bounce, then it's more likely to tag a piston than the intake valve, because when the intake valve opens, the valve is actually chasing the piston downward, and it's a lot less likely to make any contact. So a little bit more spring pressure on the exhaust side, even though it's a lighter valve, doesn't hurt anything. So I'm going to show you what the spring pressures are based on these install heights. So if we average our, went too far. If we average our install heights, we're anywhere from 1'850" to 1'870", so I'm gonna hit it in the middle. Got about 165, 166 pounds of seat pressure. So our exhaust valve lift is 616. Theoretically, again, we will check that when the cam comes and when it's time to put all this together. But if we roll to 1'244", it's incredibly hard to do one-handed. A little bit of glare. About 400 pounds, 405 pounds. That would be our exhaust valve. And if we go to 1'225", we'll get the open pressure for our intake valve. 415 or so. Those will vary depending on which valve spring, and I'll go through and check those. It's not uncommon to see a little bit of difference there, but that's the majority of it right there. 160 seat, 415 pounds open is where we're going to be at. Okay, we got our Manley Viton valve seals on. And let's load some valves in. Okay, so now we're going to check retainer to seal clearance. You just put a set of locks in the retainer on after your valve seal is on and your valve is in, and just measure in between the two to make sure that you have enough room under max lift so that the bottom portion of your retainer doesn't smack your valve seal and your valve guide. I got a 860 thousandths clearance there, and I'll make note of that on build sheet. So with a 635 lift camshaft, we are clear, way clear on that. You could park a Cadillac in between those. All right, so let's. Okay, this is one other step that I do. I just want to verify the chamber volume and just double check all of our measurements. I've already ordered the pistons and rods and crank and everything for this engine, so just need to verify that these are what they're supposed to be. So I've got my spark plug in, got my cover plate on, and it's greased up so that it won't leak, and I'm going to use my burette and fill the chamber full and get that measurement. And the result of that is that we are at a 68 cc chamber. That's about a cc to cc and a half smaller than most of the ones that I've seen have ran. That'll put us right around, with crevice volume, probably around the 10:6 to 1 compression ratio. So we're still in good shape, but you know, that's why we check everything and measure everything and document everything instead of just guessing and assuming. Okay, so we have an assembled cylinder head, and we are ready to bag it and put it up on the shelf until the rest of the build is ready. All right, guys, thanks for watching, and I was able to get 2 videos up for you this weekend, and hopefully that helps you guys out. Hit that subscribe button, and I'll probably see you next week.